as you move the distance away, the square and inverse it, that's how much the radiation is dropping. It's dropping dramatically, okay, very quickly. For instance, as I said, the tube is a 40 keV tube. By the time it gets to the window, where it's actually coming out and striking the sample, it's probably down in the 32, 33 keV range. In that little distance, it's already dropped that much. So you know that any kind of distance, it's dropping dramatically. At about, half of that 10 feet, we can't even measure it. So the 10 feet is quite a fudge factor, if you will. And then shielding, as much as possible, you want to shoot into high-density samples. Cover the window completely as much as you can. So they're not always going to be able to do that. Sometimes you have some smaller samples and things, but that's where the test stand comes in. When you have real small samples, bags of soil, things like that, it's best to use the stand. But as much as possible, shoot into high-density samples. So if you're going around testing on the ground, that's a pretty big sample, right? Not a problem. Okay. So these are a couple of agencies, you don't have to write this down, who establish permissible limits. And I don't know why the word ALAR is still on that screen, but it's there, just to remind you. But underneath there are the radiation doses that you're allowed, that these agencies have interpreted as allowable in a year's time without any damaging effects. So 5 rems for your whole body, 50 rems for your extremities, and during pregnancy, half a rem. Now that doesn't sound like very much, does it? 5, 50, that's not very big numbers. But we'll see that you have to really work hard to get there with this instrument. So these are typical radiation exposures in a year's time in these different occupations. And now we're not talking rems anymore, we're talking millirems of typical exposure, okay? So that's why I said those numbers of 5 and 50 rems, that's way higher. They're much more than you